Alrighty, welcome back everybody. We completed the whole the first section pre-security, so now we're on to the second section, which is network fundamentals. And we'll start off with what is networking. This is a pretty important lesson that's going over the basics of networking. So if you're coming from zero knowledge, it's going to introduce some really good topics, and all these topics can go extremely in depth. There's entire careers over the networking side of things, not only in InfoSec but pure network people that this is what they live and breathe every single day. So once you load up the screen, the first thing that you're going to see is this video. So this is a 23-minute video of somebody already running through this course. Or yeah, so this what is networking room. I believe that's what they call them, rooms. So if you don't like my video, just go ahead and watch that if you're having any trouble with it. Or if you want to, typically what I do when I see a video in the TryHackMe courses, I'll run through them by myself. If it's a guided video like that, I'll run through the whole course by myself, and then if there's anything that I got stuck on or if I needed assistance, then I'll just refer to the video like that. So you guys have choices. You don't have to listen to me blabble. This is for people that, you know, might actually want to hear me, I guess. I don't know. I'm making these really for a couple friends and everyone else's good benefit. So let's start off with what is networking. So networks are conceptually, they don't have to be only strictly technology adjacent. So if you're looking at these courses, I think you can already infer that we're going to be talking about, actual networks in terms of this device communicating to this device, whether it's through the internet or whether through, cables, Bluetooth, just high level. They want to express the idea that regular communication between people can be inferred to as networks. So we'll go ahead and just move right on. So what is a key term for devices that are connected together? It's a network. Then they go into what is the internet, and here's where we start to kind of get into the more meat potatoes of it. In this example, Alice here knows two languages. Her friends, on the other hand, don't know two languages. So it's like these two might speak Spanish, these two might speak Japanese, and Alice knows both. So in order for Bob to communicate to Zane or Jim to communicate to Toby, they'll have to go through Alice, which is serving as, you know, metaphorically speaking, Alice is the internet. So Jim is a PlayStation, Toby's an Xbox. They're communicating on the internet and they're doing crossplay. All right. So that's just very high level. Then we go into a little history lesson. The internet, the first iteration of it was from the late 1960s and it was called the ARPANET. All right. So ARPANET it's a word, it's a real thing. It was a project that was funded by the United States Defense Department and it was the first documented network in action. But it wasn't until 1989 when Tim Berners-Lee actually invented the internet as we know it because he made the World Wide Web. So every website, the www, World Wide Web, thank you, Tim Berners-Lee. And that's also a very good trivia name if you ever go to trivia, like a DEF CON or any other conventions or whatever. Tim Berners-Lee invented the internet as we know it because he made the World Wide Web. So uh, then it says we're going to go and look at this diagram where we have separate networks all communicating through the internet. So this would be your network, your friend's network, and a girl that she knows network. So each one of you can have private networks as they communicate through a public network though. So everything on the private network can talk to each other without going through the internet because they're just connected talking to each other. So me pinging over from my desktop to my laptop, cool. However, my desktop in my house cannot ping my friend's desktop at his house because it's on a separate network. But I could send him an email. I could play with them in a game because those are using the internet as their backbones. So the concept of having private networks and public networks is pretty important. Going into the question here. So who invented the World Wide Web? Real quick, it is Tim Berners-Lee. So TBL. Boom. Alrighty. Going on to identifying networks on devices. So much like humans, we have identifiers. I see my webcam's going a little bit wonky right here. We have our name and our fingerprints, or it could be your username, your alias, all this other stuff. But we have identifiers. Devices also have identifiers in the form of an IP address and a media access control address, or MAC address for short. Kind of funny, we did IP when that is for Internet Protocol. So the vocabulary for today, remember, Internet protocols and MAC addresses. All right, so media access control. In normal talking, like if you're at a job and stuff, you are not going to say, well, what is your internet protocol address? No, what's the IP address? And it's not what is the media access control address, it's what's the MAC address. All right, so going into IP addresses. So if we look at this diagram, it does some wonderful labeling here. So IP address is a set of numbers that has 4 different octets. So we have octet number 1, number 2, number 3, and number 4 here. And each value will summarize to be the IP address of the value on the network. So all of it together. So all 4 octets with their 3 numbers, or up to 3 numbers, because each value can be between 0 and 255 for an IPv4 address. Um, let's see, how far do I really want to go into this next part? All right, so we'll just go with what's important to understand here is that an IP address can change from device to device, but cannot be actively simultaneously more than once within the same network. So what that is saying, so if we go back to this little private network diagram, this guy could get an IP address of 192.168.0, like .1.1. This guy logically should probably have a different address in him, so it might be that 192.168.1.2. This can change, okay? We can statically assign it to be a .3 at the end, .4 at the end. It can't be a .500 at the end. Remember, it has that limit 0 through 255 type of deal. But ideally, in a well-functioning network, you're not going to have anything with the same addresses. Now, I have been in jobs where people statically assign addresses out where they're not relying on the tools like DHCP to administer IP address management. You can statically assign this guy to be .1 and this guy to be .1. You're going to have problems. All right, I'll just put it like that. They should not do that because then you're going to have issues with it. So, high level, always different. Um, Then it goes into this nice table here where if we look, we have device name, IP addresses, and IP address types. So we're really going to drill into the difference between private and public. So these device names, there's 4 entries, there's 2 devices. So we have this desktop starting with K, ending with a D, and we have this desktop CM NATIC PC. All right. So they have this IP address of 192.168.1.77, which is a private. Then they have this other one of an 86.157.52.21, which is a public. The public IP address typically is assigned from your internet service provider or your ISP, while your private is managed typically through your router, um, or whatever other service is assigning out your IP address. So, uh, enterprise, you'll have a DHCP server. The DHCP service typically is done through your router. If you're just a every modern day customer, like the off the shelf, like little Cox routers and stuff, like the Cox modems, everything's all built in one. It's already managing all that for you, so you don't really have to think about this. And it's making sure these collisions aren't happening where if it's assigning out like a 1.77, then if you power up a new phone and it wants an IP address, it's not going to give it that same 1.77. It might give it 1.78. Um, so typically on private networks, you're not going to see any of those duplicates. But if you have a keen eye here, you're saying, hey, what you're talking about, there shouldn't be duplicates, but there's 2 duplicates here. Like what's going on? That's because it's on your public network. So what the takeaway that is when the ISP is assigning like your router its public address, other devices can have that same address. So, from this information, what we can infer is because they have the same public address, they're probably on the same network. and they have different separate private addresses because they're two desktops that are in somebody's home. All right. Um, Another thing to differentiate, like I just saw this little YouTube TikTok short about this little projection cube. It was like from Alibaba or something like AliExpress. And once it started up, part of its loading sequence was it said IP address and it listed a 192.168 address. And in the comments, you had hundreds of people going crazy. I can't believe you just doxed yourself. You're an idiot. You just gave your IP address up on the internet. They gave their private IP address, okay? Like that is not that valuable in the sense of people doxing and what they're thinking about. Like, thank you for being concerned about it, but me having an address of 192.168.1.77 doesn't really carry a lot of weight because it's on a private network. Now, if somebody else is on my private network, then that's something else. But generally speaking, like we have two different IP address types, and it's very important to know the distinction between them. And you will be able to recognize the more you get through these lessons and the more you see IP addresses, you'll understand different schemas and how the different octets really represent different things. So it goes into further show the different MAC addresses. So if we're looking at this, desktop has this IP address, 177, and this says DHCP, so it was assigned its IP address through the DHCP. It has this MAC address, and then this guy over here, he got assigned this address through DHCP, so their little home router thing assigned them to .74, and here's its MAC address. So even though these are the same, they have the same identifier on the public network, they have a different identifier in the MAC address. All right. Then we go over into IPv6. So IPv4 is this. If you think of IP addresses, this is typically what people think of, these four octets, up to three numbers in each. IPv6 solved the issue that we only had so many IP addresses, so it is 2 to the 32nd power, resulting in 4.29 billion IP addresses. Sweet, that sounds like a lot. Cisco 4 years ago said we're going to estimate that 50 billion devices are going to be on the internet. All right, so 50 billion are going to be needed. We can properly identify 4.29. We need to come up with a different schema to really accommodate that. And that is when IPv6 came about, which supports up to 2 to the 128th power, so 340 trillion plus addresses. And it's more efficient due to more or newer methodologies. IPv6 addresses have all these all these characters, and if you notice, it will start using um, not only numerical numbers, but it starts using the alphabet. So you'll see A's and C's and whatnot, B's and things like that. So its format is you have four characters, colon, four characters, and it does that eight. And so you have eight colons. So if I remember this right, 1, 2, 3, 4, 5, 6, 7. I'm dumb. 7 colons, 8 different little areas here. And I'm sure as we go through the lessons, we'll get the actual name of those. So these are octets that probably call something different if I'm remembering correctly. I don't deal with IPv6 a lot. It's there, it's in the environment. It's something that you need to know about. I'm not a network expert. We're getting through this together, all right? Talking about the other identifier, though, we're moving on to MAC addresses. So that's immediate access control. These have 5 colons. There's 6 different areas. The first 3 are the identifier from the manufacturer. So Intel, Cisco, HP, Sony, whoever's making the actual device, those 3 first sections will always be the identifier for those. And then the last 6, these characters are actual unique identifiers for each, what am I looking for? The physical network interface, whether it's in RJ45 connector or, port or whatnot. Um, each one from the factory has its own unique MAC address. The thing is MAC address can be spoofed or faked. Um, that's called MAC spoofing when you do this. So if you read along here, but it occurs when a network device pretends to identify as another um, device using its MAC address. So not using its IP, but changing its MAC address. And this can bypass certain layers of security. So in this example, a firewall is configured to allow any communication going to and from the MAC address of the administrator. So if the administrator has a particular Dell laptop, the first three are going to be Dell's identifiers, and then it will have its own unique MAC address for that device. They can have 1,000 different Dell laptops in this enterprise. Administrator's laptop has its own unique identifier and its MAC address. And the firewall is configured to say anything coming from that admin's laptop, I'm going to allow. It doesn't matter if it's going to a bad place, anything, we're allowing it because that's the administrator and we're trusting them. So a bad guy can say, okay, I have all these juicy targets that I want to, spoof their Mac. I'm going to go for the administrator's one because you know, in this instance, the firewall is allowing all communication. So anything going to and from that laptop, except for physically stealing the laptop, he's just going to spoof that address. Um, that is a pretty common control in enterprises to have a way of managing the Macs that are allowed on your network. It goes on to say, cafes, coffee shops, hotels might allow access onto their network, like their guest Wi-Fi. They might have like a premium version of that allows more bandwidth or better speeds and stuff, or even just allows normal access. The interactive lab that we're about to do, we're gonna spoof somebody's MAC address there. So let's go ahead and scroll up and let's go ahead and do that. So in this example, we have two computers here. We have Bob and we have Alice, all right? And we are both trying to access the internet, like let's say at a hotel. If you notice, Alice has good flow of traffic here. Packets are going from her computer, hitting this router, moving on up to the internet. She is watching YouTube absolutely fine. Bob, on the other hand, he's trying. He cannot get any of his traffic to actually reach the internet. So he has means, he has methods, he knows how to spoof MAC addresses. He says, "Wanna know what, Alice? We cool, but I heard that you actually got signal and I didn't." So he goes and spoofs hers, her MAC address, just by copying it. And there's various ways to do that. This does not go into how to do that. Just we're doing conceptual things here, all right? And then we get a flag, so we can go ahead and copy and paste that. And good job. So we went and got our free hotel Wi-Fi. I'm doing that, and then we're gonna go down here. We're gonna paste that. Boom, got that. So we do have a couple questions here. So let's go ahead and answer them. What does the term IP stand for? First portion is gonna be internet. I'll tell you that much. Give you a couple seconds. The second part is protocol. Alrighty. Next, what is each section of an IP address called? And that's an octet. Well, judging by that, I might have been me saying whatever for the IPv6 ones. Uh, Apparently, they're still called an octet. So, how many sections digits does an IPv4 address have? That's four. That's four octets. All right. It just does for an IPv4 address, and kind of easy to remember. V4, 4. All right. What does the term MAC stand for? Oh boy, let's see. That is a media access control. Alrighty. So the MAC address. Bam, cool. On to really the last section of this, which is ping. So ping is very important. Ping allows devices to send packets to other devices and then receive a packet back. And from that, we can see how reliable the connection is, or even if the connection can exist. So you can do that internally. You can do it externally, so you can reach out websites. You can reach out to other devices to their IP addresses. You can use this for troubleshooting. It's a very useful tool to use during troubleshooting. Just see if something's up and talking, because sometimes you can have a device that's powered on, but it's not getting network connectivity, and you're like, well, what's going on here? Can it even reach out? Like, can it reach externally? Can it only see internally? Where's the problem really starting here? And ping's a very useful resource to just start off. And how you ping something is you type ping, um, Linux and Windows. That's typically the syntax. There's other operating systems. They might have a similar function that does it, but you're gonna say ping space and then the address. So you can put in the IPv4 address, so the 4 octet. So this is pinging 192.168.1.254. And then we're going to look and say, hey, we sent 6 packets, 1, 2, 3, 4, 5, 6. And this is the time it took to send a packet and receive the one back. All right. The actual thing that's called is it is using Internet Control Message Protocol packets, and it is saying an echo packet and then the echo reply. All right. So ICMP is fairly important. Remember that Internet Control Message Protocol. Internet Control Message Protocol. I can almost guarantee. Oh no, there's not a question for that, but you end up seeing that. Um, let's see. So it goes over just the basics. Boom. It does have a site, a little exercise, and it wants you to ping the address of 8888. In here, it's not really going to, you know, you're not launching Windows, you're not using command prompt here to type in ping, but you're simulating it just in this website. So, boom, we're going, hey, look, we're getting these MS values, and we got our flag here. So we got 4 packets transmitted, 4 were received, 0% packet loss. If you experience packet loss, typically you know something might be going on with the network. It could be at your place, it could be further down the line, depending on how many hops that you're going. But um, when we look at ping in milliseconds here, so it's still going extremely fast. Typically, the easiest thing I can attribute that to is if you ever play a video game and you're looking at your network health and like green bars means you have low ping, right? And that means you have a very healthy connection and it's low milliseconds. Yellow, we're getting higher and you might experience some lag. Red, you're going to get laggy stuff because it is like this MS value is kind of through the roof then. So let's answer these questions and call it a day. All right. So what protocol does ping use? What I say? Internet Control Message Protocol. So ICMP. Boom. And then what is the syntax of ping 10.10.10.10? It is going to be ping 10.10.10.10. Boom. So that's a fairly straightforward one. And that concludes task 4. On to task 5, which just says, hey, continue learning by joining this next room. I want to say that is the next room in the path. So we'll go ahead and hit complete. We get our congratulations on completing what is networking. Thank you all for watching. If you have questions about this, please just drop them down. I'll do my best to answer them. Thank you all. See you.